whale watching, in my personal point of view, it's not a passive activity. Take a boat out and observe a whale as it swims by or as it leaps at a distance. No, it's not a passive activity. Believe me, this highway runs both ways. As we observe whales, whales observe us. For me, whale watching is interacting with the ocean environment in presence of whales. And there's many ways to do this depending on the species, depending what your aim is. But when you practice responsible whale watching, you can really get a grip on how they observe us, how they feel the environment in regard how we do it. So the relationship between man and whales have changed along this past 3 centuries a lot. Nowadays, responsible whale watching is a new approach to not only manage the resource of whale watching, but also to protect the whales, and in my personal case, this is a home of the humpback whales. The humpback whales I study live in the North Pacific. They spread out in different seasons, different times of the year, between the Gulf of Tehuantepec, Mexico, and southeastern Alaska. Actually, these areas of the world are responsible for the support of 4 populations of humpback whales and a lot of other species. Not only humpback whales feed on here, also blue whales, finbacks, sei whales, gray whales, orcas, sperm whales, many species of cetaceans. Okay, another one bites the dust, right? Well, the oceanographic process prevailing in these waters in the north during summertime supports these populations of humpbacks. And the productivity in these oceans is 500 times faster than it does in the Mato Grosso rainforest in Brazil. In other words, I'm comparing how fast the life is produced in these waters during summertime, comparing it with the fastest growing rainforest on the planet. Well, the food chain energy flows 500 times faster in these waters, where there's areas between 12 and 18 hours of sunlight with a lot of nutrients. And a lot of sunlight and a lot of nutrients is a big inflow for the food chain that starts with photosynthesis. After microalgae, the next step is copepods, and the following link is krill or fish larvae, and that's what humpbacks feed on. Humpbacks feed 2 tons of drained food a day during summertime, and they accomplish this by expanding their throat grooves. All rorquals have throat grooves from the chin to the navel, allows them to expand, uptake larger amounts of water, strain the water through the baleen, and ingest the trapped food in their baleen. Like I said before, the size and the spacing between the baleen allows them to sort the right size of food they can intake, because very different than we could imagine, whales have narrow throats, not big ones. Everything about whales is huge except the width of their throats. That's why they need to intake small organisms. We're talking about shoals of sardine larvae, capelin, mackerel, anchovy, all larvae size, and big blooms of krill. Krill is a shrimp-like crustacean, 5 millimeters its largest size. And a tiny organism can double its numbers much faster than a bigger one. That's another advantage of eating on a low level of the food chain. So they don't deplete their food resource. It's like their pantry is being replenished on a daily basis. And they can eat 1.5 or 2 tons of drained food a day during summertime. It's 5 months of feeding that amount, and that allows them to grow. These cold environments in the North Pacific have low temperatures between 40 degrees Fahrenheit and 20 below. And those areas will drop the metabolic rate of the whales. So it slows down their metabolic rate, they eat a lot, and what happens? They grow 30% of their body weight, 12 to 16 tons of growth in terms of just fat. It's a dense fat, and it's peculiar how they can stash the energy between late June and late September. They can stash all the energy, grow 12 to 16 tons of weight, and at the end of September, they have to move more because the day shortens, the food runs scarce, and there's a moment when they're intaking as much calories as they're burning by moving and finding this food resource. And that's the moment that triggers a migration down south. Could be late September, could be very early October, could be earlier, depends on the weather and the blooms of plankton. It's about calorie content, calorie burning balance. So basically, when they're getting chilled because they're not replenishing calories, what do? They move south. Just like when we get cold, we move to the sunlight. Whales do exactly the same. They move south, and that's where the sunlight is. You see the sunlight tilt south real quick, mid to late September. That's the moment that they wait for to orient themselves so they know what south is. And that's how they come to Mexico. Well, they come from British Columbia all the way down to Oregon coast, and when they reach California, they find the current of California that funnels at the Farnell Islands, gains intensity and strength, and gets closer to the shoreline. So they hitchhike on this current, and they arrive to Mexico. So in this area, Banderas Bay is a transition zone between the current of California and the current of Costa Rica that is flowing from the south. Current of Costa Rica is a warm current, saltier current, so the combination of these both waters provides them the right buoyancy conditions for them to mate, to breathe. Also, when they get into Mexico, they experience an increase in temperature in the environment. Rising temperature will boost the metabolic rate, and that would allow them to be fertile. Without secretion of hormones, there's no fertility. In other words, whales are inducing themselves to an artificial spring as they swim through warmer water instead of waiting till March arrives and boosts their metabolic rate. Clock is ticking, they have reserves, there's not food available, they got to use those reserves for reproduction. That's why they swim south. Also another reason, whales love fair weather. That's why you guys are here. There's bad weather in the north. That's why whales are here. What happens in summertime? There's hurricanes on the south, there's hurricanes over here. Where are the whales? Up north, where there's good weather. So they're very smart. That's why they've been around for 35 million years. Well, these migration routes are synchronized with the gestation period of a whale, which is 50 weeks, or in other words, 11 and a half months. And the whales have these cycles, these yearly cycles, in order to suit their biological demands as a population, as a whole group. Whales all help each other. It's not about, I'm going to make sure I survive and I don't care about the rest. No, they all help each other. They feed as groups, they breed as groups, they migrate as groups. That's how they efficiently use these vast areas of the ocean. Well, after a good feeding season, whales accumulate a lot of blubber around their bodies. Particular females are larger than males. They can accumulate more blubber, particularly around the tailstock. This is where females are larger than males, and you can recognize a female on the field because they have a longer, thicker tailstock that partially covers the spine, this extra blubber. So when a female arcs its back, you can see a smooth, round profile. With our males, you can see the spine well marked. And also males have a lot of scars from the fight they get involved in. A sexually mature male will be fighting over the preference place with a female. They develop a lot of scars, so they develop also a rough appearance. They have a rough looking. Where their females are very sexy, very elegant. Their movement is so elegant, their skin so soft, and almost no scars, that they really look elegant, where their males look like rough. Look. Males in the breeding ground, when they're sexually mature, they sing. They vocalize to serenade and transmit their abilities as sexually mature males. When a male sings, usually sings head down. And vocalizations among whales are very important because they live underwater. All their demands, all their biological demands, all their functions is done underwater except breathing. Breathing they do on the surface. So they live in dark environments. They need to do vocalizations and echolocate to just locate and see their whereabouts. Also to locate other whales and relate to them. To communicate with the rest of the whales. And also to recognize the bottom topography of the ocean basins and the migration route. They do this by echolocation. So when a male is singing, not only he's transmitting his abilities as a mating mature male, he's also locating around him other whales, bottom topography, our boats, etc. It's very common to see a male singing and attract other males. Males, it's gang up or they cooperate to find a female altogether. It's much easier to find a female in a group. since they have to look that way, that way, that way, that way, in an spheric way to track a receptive female. And females are only receptive once every 3 years, so this competition can be very, very high. So you can only imagine, when they find a receptive female, they're no longer singing friends. They're no longer a pack of friends. They start competing. It's a gang of competitors. They want to prove themselves stronger and smarter. Not only a complex song will reveal that to the female, but the physical ability to get rid of the other males will reveal he has more stamina and strongest genetic pool. So females do this, they play hard to get to test the males. And for example, this is a female. If this female gets receptive this year, the dominant will pack around her, 2 or 3 of them, and other competitor males behind those males, trying to attempt to get closer, either under, surrounding, or over. They no longer sing when they're competing. They growl, they moan, they slap each other with the flippers, with the tails, with their backs, but they never kill each other. It's never a deadly fight. It's just prove themselves stronger. And the female moves off. Females, like I said before, they accumulate more blubber, they have more energy. They can sustain a pursuit longer than a male. Longest pursuit I've seen is 14 days. Can last 4 hours, 6 hours, 12 hours, 14 days. So if the female plays hard to get long enough, she will wear out the weaker males. She'll get rid of the weaker genes, and she'll select the strongest males to mate. So she's a lucky one that chooses, selects the males with the strongest stamina from the available males on the breeding ground, and she will mate with those, but only one will conceive her. The strongest sperm will conceive the egg, and then her experiment is done until then. She'll get pregnant. But you know men, you know males, they're always hopeful. The only way these males can tell she's pregnant is she sends out the message that I'm no longer receptive. First, when she played hard to get, she got rid of the males. Then she starts swimming on her side, means showing her belly to the males, both sides, and echolocating at the same time to locate the swirling males around her. That means I'm receptive. I'm showing my tutu. But when deed is done and she's pregnant, she places herself on her back, slap the flippers with percussive behavior, sending out a loud sound waves. She will echolocate with the knobs on the head of everything happening underneath while she's sending the sound waves, and she will raise a tailstock, like, don't touch my tutu, no more intercourse please, deed is done, I'm pregnant, move on, look for another gal, all of the above. And, well, the males will spread out again and restart the singing process. Locate another female and compete, and later, if they win the preferred place, they'll mate. So the task of the females in this species is select the strongest genes to inherit the offspring. The task of the males is spread out more through the breeding ground and increase genetic variability. So that's what they're doing. That's why females have more preference over certain embayments, over the breeding ground, and males move a lot more within the breeding ground. That's really what happens. Singing is very peculiar. They sing with a specific dialect according to the population they were born with. This is a learned behavior. Males also have the task to teach this dialect from one generation to the next. This dialect is changing over time. Every year they drop old phrases, they add new ones. I believe these changes they're done in a response to changes not only in the environment, but also changes in their ecological dynamics of the population, meaning changes in the number of sexually mature males and females, number of juveniles, number of seniors. That's changes in the ecological dynamics of the population. Other changes would be increase in boat traffic, for instance, the coastal development areas, more marinas, different kind of boats to be used, new kinds of engines. All this produce noise pollution. Noise pollution also creates changes in their vocalizations. And each population has a very specific dialect.